Example 7 of the quadratic time complexity. So here we're going to be looking at the selection sort. Now the selection sort operates on a big O n square. Now let's assume we are given a list, an unsorted list, which has a collection of items of 8, 0, 9, and 2. 8, 0, 9, and 2. And we have a variable called n which holds this list. How does selection sort works? Now selection sort works by picking the smallest number and then sorting it and then replacing it with the first number located in the first index. And then it assumes that the first index has been sorted and it goes out to the next indexes. Now this is how it works. Now looking at this between 8, 0, 9, and 2, we can see that 0 is the smallest, right? And we can see that 8 is located in the first index. So what it does is it picks 0 and then swap it with the number located in the first index, and then the number located in the first index takes the zero's position. So it becomes 0, 8, 9, and then 2. So it assumed that this first one has already been sorted. So the next step is to look between the 8, 9, 2, right? And here in the 8, 9, 2, the 8 becomes the first index, the 9, and then the 2. So within this, it checks and it finds out that 2 is the smallest and then swap it with 8. So it becomes 0, 8, 0, 2, 9, 8. Now it assumes that the first two has already been sorted and looks between the 9 and 8. So the smallest number between 9 and 8 is 8. So it swaps position. So it becomes 0, 2, 8, and then 9. So this is how the selection sort works. But now, how do we write an algorithm to the computer? How do we pass instructions to the computer to perform this operation? Remember that computer is dummy, and computer will not know the smallest number. So you are the one to pass the instructions to the computer to understand the smallest number. So now to write to the computer to understand the smallest number, we assume that the first index is the smallest number, and then we'll compare other index. We assume that the number located in the first index is the smallest number, and we'll compare other numbers located in other indexes with the first index. The one that is smallest will be swapped, right? The one that is smallest within here will then be swapped, will be exchanged with the number located in the first index, and then we'll move forward, and that's how we keep on doing it until all are sorted. So how do we do that? So the first thing we need to do here is to start with a for loop in for I to 0 is for I equal to 0 down to the length of the n, down to the length of n. So what this first iteration means is we are starting I is a variable which we are starting from the index 0 down to the length of n, which the length of n is 1, 2, 3, 4, which means that we are performing 4 iterations, which means that I equal to 0, I equal to 1, I equal to 2, and I equal to 3. Alright. So now we can say our minimum, right? Our minimum at first instance is I. So what it means here is this is a variable called minimum, right? So and this is I. So I is 0, right? So it means that when I is equal to 0, our mean is equal to 0. When I is equal to 1, our mean is equal to 1. When I is equal to 2, our mean is equal to 2. When I is equal to 3, our mean is equal to 3. So that is what this means, right? Then we have an inner loop, which is for j. Now, let's assume that j starts from 0, right, down to the length of n, right? So if we say j started from 0, right, and we already have a mean, which is 0, it doesn't actually make sense because what we're trying to do here is we're trying to compare j, right? We're going to compare j with this mean here, and any j number that is smaller than the mean becomes what our new mean. So instead of starting j from 0, we're starting j from I plus 1. Now the reason is this: we are trying to avoid the first index, right? Now look at how it works. Now when I equal to 0, right, the mean equals to 0, then here, our j is equal to I plus 1, right? And I plus 1 in the first instance here is 0 plus 1, which becomes 1. That means our j is equal to 1, right? So remember that this is a quadratic time complexity. And remember that the inner loops must count 3 times to get to the inner loops must count 1, 2, 3, 4, right? For each of the I. And here we're telling the inner loop to start from what? To start from 1, right? Not to start from 0 down to the length of n, which the length of n is 4. So if you're starting from 1, right? So it means that j will be j equal to 1, j equal to 2. It means that when I equal to 0 again, the mean still becomes 0 and the j becomes what? 0 plus 2, right, equal to 2. Then when I equal to 0 again, then the mean equals 0, then j equal what? 0 plus 3 and equal 3. Alright, so instead of j looping 4 times, j is looping 3 times because we are skipping j equal to 0. So for each of the j will loop 3 times for each i's, right? So j will loop 3 times for each I. Now let's come to the I equal to 1, right? So when I equal to 1, mean is equal to 1. So j will be equal to 1 plus 1, right? So equal to 2. When I equal to 1, mean is equal to 1. Then j is equal to what? 1 plus 2 equal 3, right? It stops here. Then let's, because we don't have anything like j equal 4 because it's 0, 1, 2, 3. So right, so we don't have anything. So when I equal to 1, j runs what? 2 times. But when I equal to 0, j runs what? 3 times. So when I equal to 2, the mean is equal to 2. J now will be equals to what? So this is 1. J now will be equal to what? 2 plus 1, which gives what? 3. So when I equal to 2, j only runs 1 times. Then when I equal to 3, what happens? Right? So j, there's no j, so automatically this when I equal to 3, nothing happens for j. But when I equal to 2, j only runs 1 times. When I equal to 1, j runs 2 times. When I equal to 0, j runs 3 times. Right? That's what this means. So we have a total number of 1, 2, 3, 4, 5, 6. Right? 6 instead of running up to 4 times 4, so it's running 6 times based on this instruction given to the computer, right? So now let's perform some conditional if here, right? So we have understood this, we have understood this, we have understood this. Let's perform conditional if. So if, right? So if nj, right? If nj, which our nj here, remember the j in first iteration is 1, which is 0, right? So if nj is lesser than n of our mean, right? So what this means now, when I equal to 0, mean equals to 0, j equal to this, right? Then now it means that if the nj here, remember our j is 1, so our nj is picking the value located in index 1, which is 0. So if 0 is less than, then our mean is 0, right? Then n mean is picking the value located in index 0, which is 8. If this is less than 8, So what happens, right? So what happens? So what happens is, now take the mean, replace the mean with a j, right? Replace this mean with a j, which means that, so what happens is this. It means that this is true, right? It is true. It is true that 0 is less than 8. So now this will happen. So it means that our mean now, right? Remember our mean instances from the beginning was 0, right? So our mean now becomes our new j. So our mean becomes what? Our mean becomes 1, right? You can see what happens. Our mean becomes our new 1, right? That's what happens. So, so we'll move over to the next one here, right? Move on to the next one here. Then when I equal to 0, right, our mean equals to 0. This time around, our mean, right, is no longer equal to 0 because our mean now is 1. So our mean is equal to 1. Then our j is what? 0 plus 2 equal to 2, right? So it means here that if our j is equal to 2, right? So look at our j. So our j is equal to 2, then our nj, which is n2 now, which is, we'll pick the value located in n2 here, is 0, 1, 2, which is 9, which is if 9 is less than, remember, is less than our new mean now. Remember the mean now is n1, right? Right? So our new mean, right, becomes what? Our new mean becomes what? 0, right? If this is less than 0, right? Now this is false. It is false. Nothing happens, right? Nothing happens. So our mean still remains the 1, right? Nothing happens. So now in this place here, we come over to here when I equal to 0, our mean still remains 1 here, right? Because our mean has been changed within this inner loop, right? Our mean has been changed here. So we have, so if this is this, now if the n of 3, right, which is j, so the n of 3, which is 0, 1, 2, 3, right, so it's 2. So if 2 is less than our mean now, remember our new mean is 0, right? Less than 0, right? So this is still false. So our mean still remains what? 1, right? So nothing happens. So we are coming out from the inner loop now because we have end the I equal to 0. Now we are moving over to the I equal to 1. So before we move on out from the I equal to 0, then we need to swap the position because we have found out that 0 is our new minimum number. So since we found out 0 is our new minimum number, so what we need to do here is we need to change our ni value, sorry, n, small letter ni value, right? We need to change it with our new value here, right? We need to change our ni value to our n mean, right? So you can see what happens, and we need to change our new mean equal to our ni. So we are swapping the positions. Now what this means is our ni, right? Our n mean, right, is 1, right? So which our n mean here is 1, which is 0, right? Right. So our ni initially was 0. So our ni is fetching 8, right? So what this means is that at the end of I equal to 0, right? So our ni becomes what? 0, because we have, remember the mean is n mean, which is 1. So the one, look, the value located index 1 what is 0, so 0, 1, right, is 0, right? So our n, so at the end of I equal to 0, our ni becomes 0, and our n mean becomes what? 8. So at the end of I equal to 0, the list becomes what? 0, 8, because we have swapped it, right? We have swapped it, so it becomes 0, 8, 9, and 2. Right? So at the end of this, right? So our end of I equal to 0, the list becomes what? 0, 8, 9, and 2 because we have found the smallest number and we've swapped it with this. So let's do this very well. So this is how the algorithm looks, right? So this is the inner loop and this falls within the outer loop because at the end of the inner loop here, we have sorted this and we have explained this, right? I've explained everything here. So now let's move to I equal to 1. Let's move to I equal to 1. Now, when I equal to 1, remember we're working now with this new list, which is 0, 8, 9, and 2. Right? At the end of this first iteration, when I equal to 0, the list becomes what? 0, 8, 9, and 2. Now, when I equal to 2, what happens? Right? So it means that when I equal to 2, the mean is equal to 1. The j is equal to 1 plus 1 equals to 2. Right? So now if the this is if and nj, and our nj now is n2, right? So it becomes what? 0, 1, 2. So our 2 here is 9. So if 9, our 2 here is 0, 1, 2. We're not working with this anymore, we're working with this, which is 0, 1, 2, right? Which is 9. So if 9 is less than our mean now, so our mean here is 1, right? Our mean here is 1. So n mean is 0, 1. So our mean becomes 8. If 9 is less than 8, right? If 9 is less than 8, what happens? Is 9 less than 8? So this is false, it is false. So nothing happens, right? So nothing happens. Our means to remain what? Our means to remain 1. So it comes into here when I equal to 2, mean equal to 1, then j equals to 1 plus 2, which is 3. So it means that if, so n of j, which is 3, which is 0, 1, 0, 1, 2, 3, which is 2. So if 2 is less than our mean is 8, right? Our mean is 8. If 2 is less than 8, right? So 2 is less than 8, so this is true, right? Then swap it. So our new mean now becomes what? Our new mean becomes 0, 1, 2, 3. So our new mean becomes what? 3. Right? So our new mean becomes 3. So we have end the I equal to 1 because we are out of the loop, right? So our new mean becomes 3. So what happens here is at the end of this, right? So I'll place this here. So at the end of I equal 1, at the end of I, at the end of I equal 1, right? So n of I, at the end of I equal 1, right? So n of I becomes what? N of I will be equal to what? Equal to 2. Then our new mean becomes what? Remember I is 1, which is here is 0, 1, right? So our new mean becomes what? Our new mean becomes what? 8, right? So it's the 8. So which is equal to 0, 0, 2, 9, and 8. Right? So we have solved this out. So now in this one here, now we're in the I equal to 2. When I equal to 2, the mean is equal to 2. The j is equal to 2 plus 1 equal 3. Then we'll now say, now if n of j, nj, which is n3 now, which is this new, we're working with this new one, is 0, 1, 2, 3. It means that if 8 is less than, then our mean is 2, right? N2, which is 0, 1, 2. Our mean is 9 now. So if 8 is less than 9, right? If 8 is less than 9, which is true, right? So this is true. Then swap. So our new mean becomes what? Then our new mean becomes what? Our new mean becomes 0, 1, 2, 3. So our new mean becomes 3, right? Because our j, right? You can see our new mean becomes 3. So if 8 is less than 9, which is true, so our new mean becomes 3. Then at the end of this I equal to 2, so it becomes, so at the end of I equal to our ni becomes what? 8, and our n mean becomes what? 9. So now finally we get this sorted, which is equal to 0, 2, 8, and 9. So So this is what happens, right? This is what happens when we perform this algorithm, right? So we have everything sorted when I equal 3 and min equal 3, so nothing happens, no j happens. So it returns this result for us. So when we output n, right? When we output n, the answer will now be 0289, and everything is sorted because we have used the selection sort algorithm to sort this number. I hope you understand this. You can see how it works, how it operates, right? I hope you understand this. If you have any questions, feel free to ask me. So this is the algorithm for the selection sort, and I've explained how everything works, and you can see how it works very well. I hope if you have any question, please feel free to ask me on my YouTube channel or contact me. I'm always free to answer you. Thank you and God bless you.